Hello, everyone. My name is Julia Mahood. I'm a master beekeeper. I live in Atlanta, Georgia, in the United States, and I'm going to talk to you today about the game of drones. In any given colony, will typically find one queen, about 60,000 workers, and maybe 2,000 drones. The drones are the male honeybees. They are. This is how the sex determination happens in bees. Is that the queen, when she goes to lay an egg, she'll put her head in the cell. She'll feel with her front legs. If she feels that this cell is about 5 millimeters or smaller, she will then pull her head out, back her abdomen in. An egg is released from her oviduct. A little bit of sperm is released from her spermatheca, which stores all the sperm that she's collected on her mating flights. And the egg is fertilized and deposited through her sting chamber into the cell. If, however, she feels that that cell is larger than that, when the egg comes down the oviduct, no sperm is released and she lays an unfertilized egg. We know that this is the mechanism for sex determination because they clip the wings off of queens and so that they can't tell how big the cells are. And then in those cases, the queens will lay sort of willy-nilly male and female eggs. So honeybees, like all Hymenoptera, are known as haplodiploidy, meaning that that an unfertilized egg becomes a male and a fertilized egg becomes a female. And so the drones only have one set of chromosomes instead of two. Because of this, you can see recessive genes expressed sometimes. So the dominant eye color in honeybees is black. So you can sometimes see drones with white eyes, or picture on the left, these tan, beige, or cherry colored eyes. So the drones have one job in the colony and one job only, and that is to mate with queens from other colonies. So let's look at how the drones are equipped for their one job as opposed to workers. Their antennae have 10 times more olfactory plates than workers. They have to have an incredible sense of smell because they have to smell the queens flying in the air. So they have a much larger compound eyes, many more facets than workers, and that's because they have to see these queens flying in the air. The optic lobes of the brain are much larger to process that information. They have larger flight muscles in their thoraces and broader wings. Another interesting thing about drones is they don't have a sting, which makes them kind of fun to work with. So on this slide, this is my image of bees mating in flight, and that's because you literally cannot see them with the naked eye from the ground. They're flying so high up, it could be up to 75 meters high, that it's literally impossible to see. But what we know is that drones and queens leave the nest and they fly to these specific places that we call drone congregation areas to look to go to mate, or DCAs for short. And these are areas about 30 to 200 meters in diameter. They leave the nest typically in the afternoons, although I've seen DCAs well populated 6 o'clock or at 6 to 7 p.m. at night. So it really is more dependent on the weather and the temperature than the time of day. And they get to these DCAs by pathways that we call flyways. And these are the paths to and from the DCAs. This map on the right is an area of drone congregation areas that was mapped out in Tucson, Arizona by Gerald Loper. And the black dots are the DCAs, and then these dashed lines are the flyways in between them. So a drone will head out, find a DCA, fly to a DCA, fly way up in the air, look for queens to mate with. He doesn't see any, and he may keep going down the flyways to other drone congregation areas. He can fly for about 30 minutes before he needs to head home and refuel, so he'll go home, eat honey, maybe groom a little bit, and head back out again. And he can have many flights in a single afternoon. So we don't know a whole lot about drone congregation areas, but what's fascinating is that drone congregation areas remain the same year after year after year. And one of the reasons why this is so fascinating is because there's no intergenerational learning among honeybees drones, because the drones are only around as long as they're useful, and that's the spring and summer months. And as soon as they no longer need drones to mate with, the workers will refuse them entry or kick them out, usually in the fall when they don't need them to mate anymore. So they can't teach each other, but somehow they know year after year. There's a DCA in Sheffield, England, that supposedly has people have known to see bees in it since 1722. Isn't that crazy? So there are a few cues that we know, clues, where we can find drone congregation areas. Typically, the bees will head to depressions in landscape rather than climb. And they're often open areas with a windbreak. So it could be an open field lined by trees, or a field lined by a cliff, or it could even be a parking lot with buildings lining it for a windbreak. But there's a lot that we don't know because it's difficult to find and survey these drone congregation areas. One fascinating thing about honeybees that they have evolved to cut down on inbreeding by how the bees fly, the drones and the queens fly, and how far away they go. So drones prefer to fly DCAs close to home. They have to keep going back and forth. So they will go, typically a third of a mile is a good place to look, but they'll go a third of a mile to, a mile and a half away, whereas queens fly farther away and their paths are at different heights. So workers and queens typically will fly about 8 meters off the ground when they leave the nest and fly out and go on their way. Once the queen gets to the drone congregation area, she'll go up and then meet the drones up there. Whereas her brothers, when they leave the nest, they go up 26 meters high and fly to, when they get to a drone congregation area, then they can fly up to 75 meters above the ground. So they can go pretty high once they're in the drone congregation areas. But this mechanism, the queen, when she finds a DCA, she's going to find enough drones to mate with. So she can afford the energy to go farther away and avoid mating with her brothers, whereas the drones need to stick close to home. I find this just really fascinating. Okay, bee sex is complicated. I've already mentioned it happens on the wing. So the bees are flying about 13 to 15 miles per hour when they mate. And what happens is when a queen gets into a drone congregation area, she can smell the male pheromones and they can instantly smell her pheromone in the air. So once they smell that queen pheromone, they will follow any movement. They'll line up behind it in what's called a comet. And the drone in the front of the comet will approach the queen first, and he will grasp her with his four front legs. At this point, the queen has to open her sting chamber, and if she does, then he everts his endophallus into the queen's sting chamber. And this action snaps him backwards and paralyzes him, and then his penis breaks off and he falls to his death. And this takes literally 2 seconds for a drone to mate with the queen, and it's also creates an audible popping sound that you can sometimes hear from the ground. So she'll mate with a drone, takes a couple seconds, the next drone comes along, she'll mate with him. And we know that the strongest colonies have queens that mate with many, many drones. In the books, you'll read that the queens mate with 12 to 20 drones, but there's evidence from work at the University of North Carolina that they actually mate with upwards of 50 drones. And we know that colonies that are headed by queens with only a couple, have only mated with a couple drones are really not healthy, viable colonies. The more drones she mates with, the stronger the bees are. They need that genetic diversity to have a successful colony. So when the queen gets back to the hive, she often will have the last endophallus of the drone that she last mated with still in her abdomen. It's called the mating sign. About 70% of the time, the queens come back with this mating sign. And as I mentioned earlier, if the drones don't die from mating, their sisters will eventually kill them off because they, when they're no longer needed, they expel them from the colony. The way that researchers have found drone congregation areas in the past has typically been to use a weather balloon filled with helium. And what you do is you walk around, it's got either a virgin queen or some queen pheromone lure hanging underneath the balloon. This method takes 2 people because one person has to sort of fly the balloon with the kite string. That's my buddy Courtney there. And then I'm the person right now who's looking with binoculars to see if there are any drones under the balloon. This method is expensive. There's a worldwide helium shortage. Helium's expensive. It also takes 2 people. And more importantly, it limits you to survey areas where you can walk under the balloon, right? So it's really difficult or impossible to survey areas over trees, for example. I have been working on a method to find the drone congregation areas using a mechanical drone. So just to keep things simple, when I talk about the bees, I'll say drones. And when I talk about this mechanical drone, I'm going to call it a UAV, for unmanned aerial vehicle. So this is my UAV, and I'm dangling lure below it, down here, this little black thing. The lure that works really great is this, it's a product called Temp Queen that honeybee suppliers, equipment suppliers sell. It's just a few dollars. It's impregnated with artificial queen mandibular pheromone. You can keep it in your freezer. It'll last a really long time, and it works great. So you need something to attach the lure to with a little bit of weight, and also something that for your camera to pick up on your UAV. So these cheap hair rollers work great. You just peel off the fuzzy outer layer, and then you attach the pheromone. And then I like to use thin sewing thread, like the thinnest you can get, to attach, and also use this jewelry hardware, but you don't have to. You can just tie it to the feet of your UAV. You want to use thin thread because if your lure gets caught on something, it's better to lose a few bucks in lure than in a hair roller than to crash your UAV. So this thing works great. I like to fly at a height where the propeller wash isn't artificially flooding the area with the queen pheromone. So this is me laying in my driveway, flying my drone overhead until I can no longer feel the propeller wash. And for my equipment, that's about 20 feet. So I usually make my line a little over 20 feet. And this is just a couple shots of some bees flying around the lure, the drones flying around the lure in action over a rooftop. So in order to, where should you look for drone congregation areas? We know that, you know, one of the cues is possibly depressions in the landscape. So I recommend using Google Earth Pro, and they have a feature on there where you can exaggerate the elevation, and you just bump it all the way up to 3, and then start at your apiary and look out and kind of move along landscape and see where you see some dips. And those are great places to start looking. So once you find a drone congregation area, which is super exciting, I would encourage you to pin it on this citizen science website that I've set up called mapmydca.com. And on this website, there you can read all about drones, about DCAs, and how to find them. I've outlined the method that I've been telling you about now with a little bit more information than I have time for today. And then there's also a map where anyone can click on this map and see where users have posted DCAs that they've found. And when you roll over one of the pins, you can click on this details button, and you can read, you know, if the person chose to put their name on it, the dates where they saw it, a few details. And then down here in the blue, it says click to view video. So I would encourage you to go to the website and watch some of these videos, because it's really cool to see the footage of a DCA from the UAV. It doesn't translate well, I found, over Zoom to play it, so I didn't include that, but I would encourage you to go look at it because it's really pretty awesome. So this website, my hope is that users all around will pin these DCAs, and that will just give future researchers just data. There's just so much we don't know about DCAs. It's completely free to use. Anyone can download the data at any time. I just started it in November of 2019. So right now I'm trying to get the word out to get people to use this method and to put this data up there that hopefully we'll be able to use in the future to better understand the phenomenon of drone congregation areas. One thing I don't include is how to use your UAV. It's a very complicated piece of machinery, and so that's a whole nother thing. You need to learn how to responsibly fly your UAV in order to do this. And that is the end of my talk. I'm almost at 15 minutes. I look forward to participating in the Q&A sessions, and you can reach me at any time. There's my email address. I would welcome any questions, and I love teaching people about drones. Thank you for joining me today.